Hey everybody, this is from day 1-9, question 15 from your practice. Can you go through and prove that problem, that x plus a is a factor of that big ugly expression? So I'm going to go through relatively quickly and we'll come up with a solution for that. The problem says, can you prove that x plus a is a factor of that? You could, if you wished, go through and did x plus a divided int. Oh my goodness, that would be a nightmare to go through and have to divide out. I would not do that. But I suppose you could get down to a remainder of 0 and show that it is a factor. Instead, I hope we've got factor theorem in our back pocket. So to go through and use factor theorem, I'm just going to have a little notation. I'm going to sneak in a little equals f of x to denote that big ugly expression. We'll call it a function. That then is going to allow me, so this is the blue. If I can do this, then I have proven. If I can show that f of negative a equals 0, then x minus that, so plus a, is a factor. So really all I'm doing is I'm taking that statement and kind of going backwards. X plus a is a factor if I can show that. So that is driving my decision. I am then going to take negative a and I'm going to sub it in wherever I see my variable. In this case, my variable is x. So what's that going to give me? Well, my first bracket then is going to become a negative a plus a to the fifth. And I am showing you just this generic substitution. Normally, I would say, hey, skip over that. Don't just blindly substitute. Like, jump a little further and do a little simplifying. I want this to be explicit on your page. So when you take a look on that screen, I hope that we're good, that entire first term is going to simplify to 0. My negative a plus my a, there's my 0. 0 to the fifth wipes that out. There is a 0. Then I get to the next two terms. So I'm hoping that we are not motivated to take a look at that next term and say, hey, you know what I want to do? I want to expand that binomial to the exponent 5. No, I do not want to expand that thing. But if I'm going to try to simplify this down, which I have to show that this gives me 0. Like, that's what the problem said. It said prove that it is a factor. So I have to show that it gives me 0. I might be motivated to simply expand that. I'm just going to get rid of that circle, put back in my 5. Okay, so what could I do? Well, let's zero in a little bit on those brackets. First off, do you notice that the bases of those powers are really close to being the same thing? Like, really close. So maybe what I might do is I might try to manipulate a little bit to see, can I make them the same? So if I take the bracket that I've underlined in green, and what I'm going to do inside that bracket is I'm going to factor out a negative 1. I'm just going to put a big square bracket because I'm now going to have brackets within my brackets. My big square bracket keeps my power, there's my exponent 5, but on the inside, I'm going to factor out a negative 1 from both of those terms. Okay, all I've done is just factor inside the base. I still have the other power, a minus c to the fifth. Okay, why was that maybe useful? Well, little side note of what I'm about to do in that first term. Keep in mind that when I have multiplication in my base, that's all I have here, a negative 1 times an a minus c. Multiplication inside my base. That makes my base one term. So let's just say that I pick something like this. Make my base one term, 3 times a. And now I'm going to put that to some exponent. Let's just call it a squared. We should be good that that is going to evaluate to a 9a squared. Why? Well, because it represents 3a times 3a, but then that means since my base is one term, I can apply it to all parts of the base. I don't have to expand. When I do that, that is the theory that I'm going to use on my first square bracket. I am going to take that 5 and I am now going to apply it to all parts of the base. What does that give me? Well, when I apply it to that negative out in front, really what I have then is -1 to the 5th. Then times my a minus c to the 5th. And then I still have my plus a minus c to the 5th. Okay, now that I've broken apart that power, if you want to think about it, into 2 other powers, like really I'm simplifying it, I can calculate everything I can. So that -1 to the 5th out in the front is a -1. Clearly, I'm not going to write the -1. That's horrible form. So it is my negative of a minus c to the 5th plus my a minus c to the 5th. Now, I am hoping that what you see right now is enough for you to go, okay, there's my 0. Like, let's take a peek for a second. You have the negative of something, and you are going to add the positive of that. You are going to collect 2 things that are exactly the same, just different signs. And anytime you collect 2 things that are different signs, if they're the same things, you get 0. If we struggle to see that, okay, if we struggle to see it, then let's use some substitution real quick and say maybe I'm going to let a minus c equal, I'm going to pick something, how about d? D's nowhere in the expression. What that then means is I have negative d to the 5th plus d to the 5th, and I'm hoping we see that those are going to cancel out. So after we've done that purple and we got to that 0, the only thing left for you to do is to then therefore say, therefore, x plus a is a factor, just to confirm your proof. Like to tell your reader, yeah, that was sufficient. I've now proven what I should. Okay, I hope that helps you through problem 15 in your practice. Keep going with the rest of it. Best of luck.